Hello everyone, in this video I'm going to explain how to implement blockchain technology in our iOS applications using Swift programming language. But before doing so, let's identify what's blockchain. Blockchain technology is a more secure way of sending data online without using third-party companies for security. Okay, how does it work? As the name implies, blockchain is a chain comprised of different blocks strung together. Each block contains of three pieces of information: the data, the hash, and the previous block's hash. Actually, let's identify what are these components. Data is, depending on the use, the data that is stored in the block depends on the type of blockchain. For example, in Bitcoin blockchain, the data for blockchain is stored information related to transaction, the amount of transaction and the information about two people involved in this transaction. The hash, you can think of hash as a digital fingerprint. It's used to identify block and its data. What's important about hash is that it's a unique alphanumeric code, usually about 64 characters. When a block is created, and the hash is also created. When block is modified, the hash is also modified. In these ways, hashes are vital if you want to detect any changes to made to the block. Previous hash is the hash of previous block. By storing this information, you can see how each block is linked from the blockchain. That is what makes blockchain so secure. Okay, let's look at this example. As you can see, each block contains data, hash, and previous block's hash. In this way, these blocks are linked together. Let's say if a hacker comes along and tries to modify the middle block, and every time block is modified in any way, the hash of the middle block will be changed. So that way, when the next block runs a check and sees that if the previous block's hash changed and does not match, it will not be accessible to the hacker, since it will effectively cut itself from the chain. This is what makes blockchain so secure. It's close to impossible to try to go back and change any data, while hashes do provide a great sense of security and privacy. There are also two more safeguards to keep blockchain even more secure: proof of work and smart cards. But in this video, I'm not going to explain the blockchain in detail because the purpose of our video to implement blockchain in our iOS application. So let's move on to our application. Okay, let's get started with our sample application. You can download the starter application from the link below this video. As you can see here, we have two Bitcoins account, and the first one is 1010, and which is 4,000, which has 4,000 Bitcoin in its balance. But the second one is 1011, and the Bitcoin balance is 0. So we send bitcoins to between these two accounts with send button, and we earn bitcoin with the mine button. Basically, what we are doing is observing the transaction that takes place between two Bitcoin accounts by looking at the console when the application is running. You will notice that on the sidebar, we have two important classes. One of them block, and another one is blockchain. If you open that, you will see that these classes are empty. And what we are doing in our tutorial, I will show you how to code these two classes, and we'll walk through the logic for these classes. Okay, let's get started. Going over let's start with the block itself. Let's add the code which will define a block. To begin, let's break down what is block. We earlier defined that block consists of three information: the hash, actual data to be recorded, and the previous block's hash. What we want to build our blockchain, we know that whether the block is the first or second. So, well, we can easily define in this Swift like this. Let's add three variables here. The first variable will be hash, string. The second variable will be data, also in this case will be string. And third value will be previous hash. This also will be string. And we'll put another variable which is index. I'll show you why we are putting index in the feature. Okay, this string, okay. Okay, these are the variables that are needed for blocks. Now, one last important code needs to be added. As I mentioned earlier, how every time block is modified, it hash also change. So let's put a function which is generating hash. Generate hash. It will return. It takes no parameter and returning string. It will return an SUIID dot UIID string replacing occurrences should be like this. And that's it. Okay, what's NSUID here? NSUID is an object which represents an universally unique value that leads to UID. It's a built right into the Swift and great for generating 32 character strings. This function generates UID, erases any hyphens, and returns string. Now, which is known as our blocks hash. Okay, after creating our block class, let's create our blockchain class. So like before, let's try to break down a blockchain into its fundamentals. In very basic terminology, a blockchain is nothing but chain of blocks strung together. So what we will do here, first we will create an array of blocks that we created earlier. Is equal to block. Then we will create two functions. One of them will create initial block. The another one will add extra blocks to its ends. So we'll create first function like this: create initial function, initial block, which takes as an input data string. Then we define a variable genesis block, its type of block. As it is type of block, it has all variables and functions we defined earlier in our block class here. So we will have genesis block dot hash is equal to dot generate hash. Then the data will take the data as parameter, and as this is initial block, previous hash will be 000, and as this is initial block, the index will be 0, and we will add this one to the chain. And that's it. This is our first function, And our second function will be the similar like this, but we will use there to create new block. So I'll copy and paste this, and just change the name of function. This will be create block, and it will take data, and here instead of Genesis block we will put new block, and I'll change all of this. It will create hash we'll use, and data will take same as the parameter, but previous hash we should take previous blocks hash. So what we'll do here, we'll go to chain array and take the value for the previous block. And the index will be the count of chain. And that's it. We are done defining our blockchain. Okay, after finishing this blockchain class, let's move on to our main view controller class. We can see that here all outlets are connected. All we need to do is handle the transaction and print them to the console. But before coding here, we should explore the Bitcoin blockchain a little bit. Bitcoins come from an overall account. Let's say this account will be initial account, which is 0000. When you mine a Bitcoin, it means that you solve some math problems, and Bitcoins are issued a certain number of rewards for you. This provides a smart way to issue the currency, and also creates an incentive for more people to mine. In our app, let's make reward for 100 Bitcoin. Okay, to do so, we need to define variables. First, it will be let first account is equal to our first account is 1010, and let second account is equal to 1011, and we will define a variable which is called Bitcoin change. Let be Bitcoin chain is equal to type of Bitcoin chain class, and let reward will be 100, and we need a master account from where all Bitcoins come. This is our initial account with 0000, so we will write like this: var accounts, it will be a dictionary string, integer is equal to 0000, and here we will have number of Bitcoins 1 million. Okay, next variable is we also define an alert which will be shown every time when the transaction could not be completed. We will let invalid alert is equal to UI alert controller. Let's select from here. Title will be invalid transaction. As a message, let's put something like this: please check the title of your transaction. Then preferred style we need to put .alert. And that's it. This is our variables. The next, what we are going to next is to code some generic function which will do some which is for handling transactions and printing the details to the console, and the final one will be verifying whether the blockchain is valid. We will do it checking the previous blockchain's hash with the current one. So let's create first function. Our first function will be transaction function. I'll create it here. Let me go here. Function transaction. It will receive 4 parameters from which account it comes, string, and then 2. This is also a string. Then amount of transaction, amount is going to be integer, and type of transaction. It might be normal transaction or initial transaction, string. And this function will not return anything. So firstly, we will check that if from account is exist, then we will continue the transaction. If it does not exist, we will show the invalid transaction alert. So what we are doing, if account from is equal to null, then self present invalid alert animated true completion nil. Return. Else we are continuing to the transaction. If accounts again from minus amount is less than 0, then again we are giving invalid alert and return. Let me copy it from here and put it here. Else we are continuing with the transaction. Account dot update value account from amount t from, and that's it. This is our first check for first account. Let's continue with the second account. I'll comment here to check second account. Here what we will do, we will check that if the account exists, then we are continuing to transaction. If it does not exist, we will continue, we will leave it as it is. then account, if account to equal to now. In this case we are just updating the amount itself. Let me copy this and remove this to make things easier. Else we will again pass this and amount to key. We are updating the amount. Okay, third if condition in our function will be if this account is if the type of transaction is Genesis or not, if it is initial transaction or not. If it is initial, we will call create initial block, otherwise we will call create block. If type go to Genesis, we will call Bitcoin chain dot create initial block, which will be, the data will be string like this, from to then amount Bitcoin BTC. Else if type is normal transaction, type is equal to normal transaction, normal. Let's put it like this, normal. Then we will call Bitcoin chain create block with the same parameter. Let me copy this parameter from here to make things easier. Okay, this is our third if statement. If there is a transaction involving a Genesis block, we create new Genesis block, otherwise we create new block storing the data. Okay, this is our transaction function we created. Okay, after adding a transaction function, we need to add another function, which is a printing function. At the end of every transaction, we want to see a list of all transactions to make sure that everything is going on. So after transaction function, we'll write change status function. Actually, I have written this before. I'll just copy and paste this not to take too much time. Here I have change status function, change state function. If I copy and paste it here, what we are doing here is just simpler. It's a simple loop where every block in Bitcoin chain we print the block number, block hash and previous hash and the data. So we update the labels, then we update the labels on our UI so that they show the correct amount of Bitcoin. At the end, we are printing the accounts and chain validity. This is another function we need to write to check the validation of chain. How we are doing this, it's checking the previous hash of the block that matched the current block. So this is function for this. It's like similarly like before, we iterate over every block in our Bitcoin chain, and we check to see if the previous hash of block matches with our current block. So if this matches, then the chain is valid. And that's it. We have finished all our functions. Now what we are going to do, we will just link everything together. So when our app first starts, it calls our view did load function. Here what we're going to do, we want our initial account 000 to send 50 Bitcoin to our first account. From there we'll have first account to give 10 Bitcoin to the second account. This can be done just 3 lines of code by calling our function that we wrote before, transaction function. What we are doing here, we are just from going to be like this, from 000 to our this, okay, then amount is 50 Bitcoin, and type is, as we mentioned before, if it is the initial account, we are putting it here Genesis. Then we are calling same function for normal accounts, which is taking the from first account to second account, from first account to second account, amount 10, and the account type will be normal. Chain state. Okay, and then we also need to add OK function to our invalid transaction alert. So we are calling serve invalid add action UI alert action. It's going to be title, okay, action style will be default, and handler will be nil. And that's it. When we start our application, it will call a transaction function for initial account, then transaction function for normal account to transfer bitcoins from 000 account to first account, then 10 bitcoin from first account to second account. Then what we are going to do next is to write our mining functions. In the first, as you see in the below, we have 4 functions here: red mine, green mine, and red set, green set. In the first mining function, we use our transaction function to send 100 Bitcoin from initial account to our first account. We print that a block was mined and print chain state. Similarly, we send 100 Bitcoin to second our account in the green mine. Okay, how we're going to do this is just, actually I copied this now. Let me copy function from here, transaction function. Then I'll change the parameters. I don't want to rewrite it again. So from first account it's sending to 100 Bitcoin, and the type will be normal, and we will print out print new block mined by, actually this is mined by first account, that's why we'll put here first account. Then we will put chain status state. It's going to be same as for the red mine, just here we will, for grid mine, here we will change from 00 to second account, and again second account here. Okay, that's it about mining functions. Then we will write sending functions. First here we will check the amount, red amount and green amount, text field. If it is empty, we will display an alert, otherwise we will continue to transaction. So how are we going to do this? It's going to be like this: if red amount dot text equal to null, then we will present invalid alert, animated should be true, and completion will be nil. Else we will continue to our transaction. Transaction will be sent from first account to second account with the amount that we put in our red amount text field. So let me copy this transaction function from here and put it here. I'll change just parameters. Transaction will be sent from first account to second account. Let me copy this. First account to second account. Amount will be this accepts integer, so I will convert it to integer. Red amount dot text. This will not be null, that's why I put like this, and the transaction will be normal. Then we will print out the amount that's sent from first account to the second account. Okay, print red amount dot text Bitcoin sent from first account to second account, and that's it. Then we will again check the chain status, because our chain should be valid while we are doing. Then red amount text will be null. We'll clear the red amount text. The same things will happen here. What we are doing here, I'm just copying this same piece of code and put here, and we'll change to accordingly. So here will be green amount. Again, alert will be the same. Then transaction from second account to first account. Amount will take from green amount. Amount will take green amount, and we'll print out green amount send from second account to first account, and we'll put green amount to null. If we run our application from front end, it will look like just a normal transaction app, but what's going on behind the scenes we will see from the logs. Okay, let me enable debug window, and this is our application. You see that when you open the application, it created a 0 block with the new hash, and previous hash is 00, and it says that data from 000 account to 1010 account and Bitcoin. And we have first block, which has a new hash, and previous hash is equal to block 0's hash number. So if I click the mine here, it will create another block. You see that new block mined by 1010, and in our chain we have block 0, block 1, and block 2. And every time when new block is created, previous hash from the previous block is taken. If we compare the hash number of block 1 with the previous hash number from block 2, you will see that they are same. And we can easily play around on this application and send from 10 Bitcoin from account 1 to the second account. We will see that it will decrease from here and increase in the second account. But what happens in the background, you see that 20 Bitcoin sent from 1010 to 1011, and it is included the chain blockchain here. If the anything happens in one of these blocks, then the data is crashed and it will not reachable by hackers, and that's it. And that's how blockchain is working. Please note that in a real cryptocurrencies backend, the implementation will not look like this. In this tutorial, I'll just show you how the blockchain is work, and this is just for learning purpose.